Okay, so we want to calculate, what are the sizes of the subsets are. So, so there are two cases. Case number one, let's just like do a more special case. Suppose that all the PIs are distinct. All the PIs are different. Okay, so essentially what we mean is that P1 is not equal to but greater than P2 is greater than P3 ... greater than PR. So then, what are the number of possible elements so what are the number of possible subsets? Okay, so here we are just talking about the subsets. We don't care about whether how those elements are chosen. Okay, we are not counting the elements of the group. Okay, so essentially at the beginning, what we want to do is that how can we take, say, n objects because there are n places, and how can we fill that up into little bins of sizes P1, P2, P3 ... PR. Okay, how many ways we can do that? So first we have, say, let's start with this one. So the first object can be chosen in n ways. It's the second object in n minus 1 way, and ... n minus PR plus 1 way. Okay, so let's put a bracket around that. And because we don't care about the ordering of these things, we have to divide it by PR factorial, right? So then we move on to the next one, and then there you can choose the first object in n minus, say, P of R ways, and then you go down like that until the size, and then you divide it by PR minus 1 factorial, and you continue doing that until you are down to only one object. And that one you have to divide by P1 factorial. Okay, so if we write this, we get that in the numerator, we get n factorial, and in the denominator, we get I1 to R, then P of I factorial. Okay, so these are the number of possible subsets. Okay, not the number of possible elements.
Would you please explain what's the difference between P2 is equal to P2 and here the something is greater than something? I mean, they're not equal, the P's.
Yeah, right. For example, here, we chose where the two subsets are equal, right? Here we chose two of them being unequal, one being unequal. So we could have taken two. We could have asked what is the size of 3,1. So this would be the case of where all the P's are different, right? This is what we are considering here. All the P's are different. Okay.
Okay, got it.
It's a very special case. Okay, so once we know the number of, the number of elements, the size of the subset, we now want to make sure that we count the number of elements in that subset. And to do that, we know that each of these, so if I take a PI cycle, if I take a pi cycle, then so each of the cycle is equivalent. Well, I should say, if I look at the pi cycles, then pi of them, would be equivalent under cyclic permutation. Okay, so that means that for each pi cycle, we are going to have pi minus 1 factorial independent elements. Okay, so what do I mean by this? So suppose I take a 4 cycle, say 1, 2, 3, 4. So this cycle is the same as this cycle. These are the same elements, right? Because they do the same thing. And that's equal to, say, 3, 4, 1, 2, and that's equal to 4, 1, 2, 3. That's what I mean by, if I take pi cycles, pi of them will be equivalent under cyclic permutations, right? So this number for each of these guys, we have to multiply by PR minus 1 factorial. So if I do this, then I'm going to have I goes from 1 to R, pi minus 1 factorial, n factorial divided by pi factorial. So here the cancellation gives me I goes from 1 to R, n factorial divided by just pi. So this is the number of elements that are in that subset we are calling P1, P2, dot, 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 PR, when all the P's are different, okay? So that is a very special case, but now we do the more general case. In the more general case, we can have JI PIs. So for example, what we did here, right? Here we had 2 of the P's were equal. Here we had 2 of the P's being equal. Okay, so in the general case, this is what we'll have. And just by looking at this formula, what we will have is that we will essentially have I going from 1 to R. So again, R is just, so now, the sum over I is going to give me, there are JI PIs. The sum over JI times PI is going to give me N. So I is now running over the different sizes. I is now running over the different sizes of PI, but for a given PI, there could be JI of those cycles. So in this formula, then in the numerator, we'll have the same n factorial, but here we'll have essentially pi to the power ji. But these different cycles of ji sizes, they themselves, there's going to be like redundancy in being able to choose them. So therefore, we are overcounting here. So we have to also divide by ji factorial, right? Is this clear why we're doing this? Because if you have like two cycles, say we have 1, 2, and 3, 4. We also have 3, we can also have say 3, 4, 1, 2, right? So, but these two things are the same. So we have to divide, we have to divide by the number of possibilities there, which are equivalent. Okay, so what we have in the end is that the number of elements in a subset which has, say, disjoints, P1 cycles, say J1 P1 cycles. J1 is the number of P1 cycles, and J2 P2 cycles. JR PI cycles. So this number is then given by n factorial divided by product I goes from 1 to R, P of I, Ji times Ji factorial. Okay. And here, we have ordered the PIs in such a way that P1 is greater or equals to P2, is equal to greater than P3, ... PR, with all the JIs either being 1 or greater, and R goes from n to 1, and the sum over JIs, PIs give me n. Okay.
Sir, I have a confusion.
Yeah.
What exactly do each of the P's signify? I'm not sure about that.
Yeah, each of the P's signify the size of a cycle, of a disjoint cycle. So for example, here, let me just give you an example. So suppose we were discussing S4, right? So for S4, let's look at say P1 equals to 2 and P2 equals to 1, where J1 is 1, J2 is 2. So what does this mean? So we write this as 2, 1, 1, 2. So this is the size of the cycle. This is the number of cycles. So what do these things correspond? They correspond to these things that we tabulated before. So here you see that we have a 2 cycle, 1 1 cycle, 2 1 cycles, okay? So the P's are corresponding to the size of these each cycle, okay? So
I see.
Here, so we already calculated manually that this is going to be a set of size 6, right? And what we did here is that we have actually figure out a master formula for this for the size of this set.